Picture yourself as a farmer thousands of years ago. You're standing in a field, watching your cows return from a long day of grazing. You need to know if the whole herd made it back safely. But here's the catch. You don't have words for 1, 2, or 3. Spoken numbers do not exist yet. How do you check your herd? The earliest solution was incredibly simple. For every cow that walked past you, you would drop a single pebble into a pouch. If the pouch was empty at the end of the line, you knew every animal was safe. Early mathematics was a hands-on tool for survival, built on the physical matching of objects in the real world. Pebbles work well for a small herd, but imagine trying to keep track of a massive city's grain supply or counting the exact number of days until the next harvest season. You cannot carry thousands of heavy stones around in a bag, and if you need to send a record of your trades to a neighboring town, a heavy sack of rocks isn't very helpful. Patiently, physical objects hit their limit. To manage larger societies, people were forced to invent permanent marks that could stand in for those physical objects. To see how that happened, we can look at Mesopotamia, roughly 4,000 years ago. This region was an early hub for recording quantities. This ancient clay tablet shows exactly how they wrote their records. Instead of ink, scribes pressed a wooden stick into soft clay to make distinct wedge shapes. This sequence shows how they built their numbers. A single vertical wedge meant 1, 2 wedges meant 2, and when they reached 10, they turned the stick to make a sideways chevron shape. However, they didn't count in groups of 10 like we usually do today. They organized their numbers into groups of 60. This is known as a base 60 system. That ancient choice is still quietly operating in your life right now. It is the exact reason why we divide a single hour into 60 minutes and a single minute into 60 seconds. Those early scribes are long gone, but the way they decided to count still dictates how we measure our time every single day. But the Mesopotamian system had a serious flaw. If you wanted to write a very large or precise number, you had to keep adding more and more individual wedges together, resulting in a confusing, cluttered pile of marks. Without a cleaner way to write down large numbers, performing advanced calculations was incredibly difficult. Mathematics was stuck behind a wall of complexity. The elegant solution we use today comes from ancient India, roughly 2,000 years ago. Scholars there developed a streamlined set of only 10 distinct symbols. To make those 10 symbols powerful, they paired them with a new rule called place value. This diagram shows how place value works. We have 3 separate boxes, the ones place on the right, the tens place in the middle, and the hundreds place on the left. If we want to write the number 375, we put the symbols 3, 7, and 5 into these slots. Because that 3 is sitting in the left-hand box, it doesn't mean 3 anymore. It automatically means 3 hundreds. Position dictates value. By simply moving a digit one slot to the left, it instantly represents a much larger quantity, all without needing a new symbol. But there was a hidden trap in this system. What if you want to write a number like 305? You have 3 hundreds, 5 ones, but no tens. If you leave that middle box empty, the 3 and the 5 slide together, and suddenly it looks exactly like the number 35. An Indian mathematician named Brahmagupta formalized the solution to this exact problem. He treated nothing as a usable numerical value of its own. He gave us the number 0. Dropping a 0 into that empty tens box physically locks the 3 and the 5 into their correct positions, preserving the number 305. This symbol for empty space enabled the place value system to function, allowing humanity to calculate anything in the universe. These 10 symbols, including the 0, eventually traveled out of India and into the Arab world. There, they were studied and popularized by brilliant scholars like Al-Khwarizmi. From the Arab world, these numerals slowly made their way into Europe over the next several centuries. By the Renaissance, they had replaced Roman numerals entirely, becoming the global standard. The digits in modern textbooks are a refined, surviving technology born from thousands of years of human problem-solving.